This lesson is going to be on the different types of scale relationships that we have. We have these three quadrilaterals, and we're going to see what we notice and what we wonder. First thing I notice is that they are all the same shape. One is the largest, one obviously is the smallest, and one is the medium size. The main thing I want to wonder or know about is if these images are actually scaled copies of each other or not. So we're going to make a measure at least one of the corresponding angles using a protractor. So we're just going to talk about the corresponding angles and give the measurements. So the corresponding angles, angle B corresponds to angle F and angle J. Angle C, which is the top angle, corresponds to angle G and to K. Angle D corresponds to H and to L, and angle A corresponds to E and to I. Now I measured them, so I'm just going to give the measurements. So angle B is 125 degrees. Angle F is also 125 degrees, and angle J is 125 degrees. Angle C is 90 degrees, G is 90 degrees, and K is 90 degrees. Angle D is 95 degrees, angle H is 95 degrees, and angle L is 95 degrees. Angle A is 55 degrees, E is 55 degrees, and I is 55 degrees. So the main thing I notice is that the corresponding angles are all the same or equal. Now, we're going to look at the sides. The problem with trying to find the sides to determine if they're scale copies is that the sides are slanted. Sometimes you can just make up your own sides. So we have this side here inside, which measures the width of the diagram. That's BD, and that dimension is 4. In this first quadrilateral, that corresponds to FH, and that distance for FH is 6, and it also corresponds to JL in my last quadrilateral, and that dimension is 2. Then we can also find how the height of it using AC, which we determined was 6, and that corresponds to GE. So GE is 9, and it also corresponds to KI, which is 3. So what I notice when I look at these is going from quadrilateral ABCD to EFGH, it's being multiplied by 1.5 for both of them. And going from ABCD to IJKL, it is being multiplied by 1/2. So since the angle measures were all the same, the corresponding angle measures were all the same, and the length and the width of the shape was in the same factor, we can say that these images are scaled copies. If we look at this next diagram, or next example, we have two quadrilaterals. Mine says the polygon QRST is a scale copy of polygon MNOP. In order to have a scaled copy, two things have to be true. The first is that the corresponding angles are all equal and all dimensions change by the same scale factor. So first, let's look at the side lengths here. I can't measure these slanted side lengths, so I'm going to have to use the other sides. So I'm going to use MO, which is the length or the width of the first polygon. So MO is 6, and that corresponds to QS, which is 4. Then I can use the height, which is NP, which is 9, which corresponds to TR, which is 6. So I notice that this scale factor is being multiplied again by 1.5 or 3/2. So the dimensions are changing by the same scale factor. But now to check the angle measures, if I measure angle P, the measure of angle P is 140 degrees. The measure of angle T is 115 degrees. Since those corresponding angles are not the same, these two images would not be scaled copies. And the reason being is that the corresponding angles are not equal. And if we look at one more example, here are two more quadrilaterals. Kieran says that they are scale copies. Lynn disagrees. Do you agree with either of them? So remember, to be a scale copy, two things have to be true. Corresponding angles are all equal. 120 and 120, 120 and 120, 60 and 60, 60 and 60. So the corresponding angles are equal. But if I look at the scale factor, this is 2 times 1/2 to give me 1, but 4 times 1/2 is not 3. So these would not be scaled copies because the scale factor is not the same for all dimensions.